Let's break down the different types of transmitters used in instrumentation. These devices convert physical measurements into electrical signals. Signals that can be used for monitoring, control, or safety. We'll run through each type briefly, just enough to give you a solid overview. First up, pressure transmitters. They measure the force exerted by a fluid and convert that into a signal. There are a few types. Absolute measures against a vacuum. Gauge measures against atmospheric pressure. Differential measures between 2 points. Sealed uses a fixed reference. Most output a 4 to 20 milliamp signal or something digital like HART or Modbus. Smart units offer temperature compensation, diagnostics, and remote calibration. Next, flow transmitters. They measure how much fluid is moving through a pipe. Differential pressure types infer flow from a pressure drop across a restriction. Mag meters use electromagnetic induction, but only work with conductive fluids. Ultrasonic types use sound waves, non-intrusive, but sensitive to pipe condition. Coriolis meters measure mass flow directly, very accurate, but expensive. Most output 4 to 20 milliamp or digital signals. Smart units can detect bubbles, pipe issues, or fluid changes. Level transmitters measure how full a tank or vessel is. Hydrostatic types use pressure at the bottom of the tank. Ultrasonic and radar types bounce signals off the surface and measure echo time. Radar works better in vapor or steam. Capacitive types measure changes in capacitance. Smart units can detect foam, false echoes, and tank geometry issues. Temperature transmitters take input from a sensor, usually an RTD or thermocouple, and convert it into a usable signal. RTDs are accurate and stable but limited in range. Thermocouples cover higher temperatures but are less stable. Transmitters can be head-mounted or DIN rail-mounted. Most output 4 to 20 milliamp. Smart units can auto-detect sensor type, compensate for lead resistance, and store calibration data. Position feedback transmitters track the movement of valves, actuators, or mechanical travel. Potentiometric types use resistance change. Inductive types like LVDTs are non-contact and accurate. Optical encoders use light and a coded disc. Smart transmitters are often built into valve positioners and can report travel time, stiction, and mechanical health. Vibration transmitters monitor rotating equipment, pumps, compressors, turbines. Piezoelectric accelerometers measure acceleration. Velocity sensors are used for lower-frequency machinery. Proximity probes measure shaft displacement, used in high-speed gearboxes. Proximity transmitters detect the presence or absence of an object. Inductive types work with metal targets. Capacitive types detect any material with a dielectric constant. Photoelectric sensors use light beams, great for fast-moving objects. Ultrasonic proximity sensors use sound waves, good for transparent or irregular surfaces. Used for automation, safety interlocks, and object detection. Conductivity transmitters measure how well a liquid conducts electricity. Used to monitor dissolved salts, detect contamination, or control chemical dosing. pH and ORP transmitters measure acidity and oxidation reduction potential. Essential in chemical processes, water treatment, and food production. Humidity transmitters measure moisture in air, used in environmental control. Gas detection transmitters monitor gases like methane, hydrogen sulfide, or carbon monoxide, critical for safety. Torque and strain transmitters measure mechanical stress, used in motors and drive shafts.